Hello. My name is Dr. François Ricard. I am an osteopath and a PhD. I am director of the International Madrid School of Osteopathy, EOM, and president of the Scientific European Federation of Osteopaths, SEFO. In this series of 2 videos, I am going to present the diagnostic tests and the cheapest material you can use to reveal an imbalance of the neurovegetative system. The first video will deal with tests based on the study of heart rate, pressure, and the ECG to show an imbalance in the neurovegetative system. The second video will deal with the material or equipment to reveal an imbalance in the neurovegetative system. Equipment for diagnostic tests for the neurovegetative system. To study the predominance of the orthosympathetic or parasympathetic system, there are several materials in medicine that can be used in the diagnostic tests of the neurovegetative system. The blood pressure monitor allows you to study blood pressure. Polar H10 strap allows you to study your heart rate. The NerveExpress software and the KUBIOS HRV software that communicate with the Polar H10 study allow, through the heart rate and the EKG, to study the components of an orthosympathetic or parasympathetic imbalance. The hand dynamometer, ice bucket or cold pack, inclination table, are useful tools to study the responses of the neurovegetative system to stress. NerveExpress, USA. Although there are some tests that do not require equipment and can be used to study the neurovegetative system, autonomic nervous system or ANS, it is highly recommended to use the material described here. Most of the people working with ANS use the NerveExpress system sold in the US. Its total price is US $3,886, plus shipping costs from the US, plus customs costs. Tools used. The cheaper material that I recommend using is the following. From the Polar H10 belt, we can perform the chosen test with our mobile phone, using the app ELITE HRV, heart rate variability, which is free. With the mobile phone we will send an email to our computer or tablet, with the data from the app ELITE HRV. Then we will open the free KUBIOS HRV Standard software installed in our computer, and it will automatically retrieve the HRV score data recorded in the email, and analyze the neurovegetative system. We are now going to detail the different necessary steps. The first step is to buy the Polar H10 belt, compatible with the NerveExpress and KUBIOS, which was priced at $86.54 when purchased. If your computer does not have a Bluetooth system, most laptops already have it, you would need to buy an adapter at a very affordable price, $9.99. Once installed on the computer, the Bluetooth system must be connected to the already connected Polar H10 belt system. Therefore, for Windows 10 go to Start/Settings/Bluetooth and other devices/Add Bluetooth and other devices. Once the Polar H10 is detected, it should appear in the device list. Next, you must install the free ELITE HRV app on your mobile phone, and the free KUBIOS HRV Standard software on your computer. On your mobile phone, install the free ELITE HRV apps. Then, on the phone, fill in the entire form, verify the phone's Bluetooth connection in ELITE HRV, choose Connect Polar H10 and perform the test. Once the chosen test is finished, Finish appears on the phone, then an account export data, The app's ELITE HRV automatically sends the data to your email address, where you must click on the blue link that appears, and the phone data is automatically transmitted to the KUBIOS HRV software. Heart rate variability, or HRV, is an accurate and non-invasive measure of the neurovegetative system, which responds to everything. Unlike the basic heart rate or HR, which counts the number of beats per minute, HRV takes a closer look at the exact changes in time between successive heartbeats, also called interbeat intervals, RR intervals, NN intervals, etc. In sinus rhythm, this interval must be constant. The RR interval is measured from the start of one R wave to the start of the next R wave, and its duration depends on the heart rate. The term NN is used in place of RR to emphasize the fact that the process times are normal times. The RR interval is the distance between two successive R waves. Intervals showing heart rate variability. Short readings of heart rate variability allow us to know the normal patterns of the autonomous nervous system, helping us to obtain information on nervous system, stress, and recovery activity. A healthy nervous system has a balanced, but strong function between the sympathetic and parasympathetic systems. Heart rate variability is an accurate measure of the balance between the sympathetic and parasympathetic systems. Higher resting heart rate variability scores indicate the body's ability to activate an increased parasympathetic response. High heart rate variability is correlated with increase in fitness level, better health and neurovegetative balance, better resistance, calm, positive emotions. Lower resting heart rate variability scores translate into increased sympathetic response, or parasympathetic inhibition. Indicates the inability of the body to activate recovery or the depletion of recovery capacity. This can be a chronic response to stress that results in reduced health and increased risk of disease. Low resting heart rate variability is associated with reduced fitness level, poor health, increased risk of disease and inflammation, increase in biological age, negative emotions, increased anxiety and depression. The ELITE HRV app allows heart rate variability measurements to be tagged for analysis of results, and provides neurovegetative guidance based on heart rate variability. To avoid errors, it is particularly important to standardize the position for all measurements. The app indicates that you should always use the same position for measurements. Lying down, if the heart rate is above 50 beats per minute. Sitting, if it is below 50 beats per minute. Test duration. The app collects data for a period of 2.5 minutes. In practice, the most common measurement index is the RMSSD, and it can be recorded in short periods of time, for example 10 seconds to 1 minute. A feasible measurement time. RMSSD, or root mean square of successive differences between normal heartbeats. It is the square of the mean root of the union of adjacent RR intervals. It provides an indicator of vagal cardiac control, that is, parasympathetic tone. Corresponds to short-term variability. Sympathetic dominance is observed in stressful situations, while parasympathetic dominance is the usual and ideal state. An excess of parasympathetic activity is abnormal, and can occur for various reasons, such as overtraining or chronic stress. The KUBIOS Standard software must be downloaded from the internet, which is the free version. Choose HRV Standard, and install. Open the KUBIOS Standard program, search in Files, select it, and click in Open a New File. In the folder that opens, select the file, and click Open. The folder where the files of the polar H10 belt are stored will open, then choose the RR type files. A KUBIOS HRV graph appears containing the analyzed data. In the upper part you can see the performance of the test. As an example, the heart rate response to postural change test, over the 3 phases. The recording of the decubitus phase, the intermediate phase of position change, and finally the recording of the standing phase. Other data of neurovegetative interest appear below, as the indices of the parasympathetic system in green, and orthosympathetic in red.
Then, click on Report Preview to launch the PDF with all the data. Then the PDF opens. KUBIOS HRV Premium results for exercise tests saved as a CSV formatted text file, showing time domain, frequency domain, and nonlinear HRV analysis results for different exercise protocol time periods.
In the PDF you can analyze the data and study the predominance of the orthosympathetic or parasympathetic index in green PNS or parasympathetic nervous system, and in red SNS or orthosympathetic nervous system. It should be noted that there is a paid version of the KUBIOS software that also allows the patient's EKG to be recorded during the tests. Its price is $385, or much more. The heart rate variability analysis software is suitable for clinical and public health researchers. Heart rate variability is an accurate method of assessing autonomic nervous system functioning, using the cardiovagal test. The results of the analysis reflect changes in cardiac autonomic regulation, and can be used, for example, to assess stress and recovery. In PDF, you can analyze the data, and study the predominance of the orthosympathetic, or parasympathetic, index in green PNS or parasympathetic nervous system, and in red SNS or orthosympathetic nervous system. It should be noted that there is a paid version of the KUBIOS software, which also allows the patient's EKG to be recorded during the tests. If you have a complete EKG system, its price can be $385 or much more. The KUBIOS software analyses have as goals: 1. Comparing the heart rate variability parameters of the selected analysis segment, and the normal resting values. 2. Producing an overview of the recording of the parameters of HRV, mean RR, mean HR, RMSSD, SD1 and SD2 derived from the Quantitative Systematic Review of Noonan et al., 2010. 3. Indicating the tone of the sympathetic and parasympathetic systems, looking for an imbalance in the neurovegetative system when it is subjected to stress. What are the KUBIOS software results parameters? HRV, heart rate variability. Average RR, time interval between successive EKG waves. Average HR, heart rate. RMSSD, root mean square of successive RR interval differences. SD1, percent or standard deviation 1. SD2, percent or standard deviation 2. Stress index. Root square of the Bievsky stress index. Values between 50 and 150 are considered normal. SNP, parasympathetic nervous system. SNS, sympathetic nervous system. The parameters of heart rate variability, which reflect the tone of the parasympathetic nervous system, are mean RR, or time interval between successive R waves of the EKG, RMSSD, or mean of the square root of successive interval differences RR, and SD1, % standard deviation 1. The heart rate variability parameters which reflect the tone of the sympathetic nervous system are mean HR or heart rate, stress index, and SD2 or % standard deviation 2. EKG and heart rate. In electrocardiograms, the paper runs at a speed of 25 mm per second. This is represented on paper by 25 small squares, or 5 large squares. Therefore, every 5 large squares represent 1 second on the electrocardiogram. With a regular rhythm where, from lead 2 there are 5 large squares between 2 R waves, to calculate the heart rate in this EKG, 300 is divided by 5, frequency of 60 beats per minute, BPM. Calculating heart rate using the number 300. It is one of the simplest methods to calculate heart rate on an EKG. This method can only be used if the patient's heart rate is regular. To calculate heart rate with the number 300, the RR interval is used. What you need to do is locate an R wave that matches a thick line on the EKG paper. The large frames that are up to the next R wave are then counted. 300 is then divided by the number of frames. It is important to remember that every 5 of these large squares represents 1 second on the EKG. Example: if there are 3 squares between 2 R waves, 100 BPM, or beats per minute. If the second R wave does not match, it is important to remember that each large square on the EKG paper equals 0.20 seconds, and is made up of 5 small squares that equals 0.04 seconds. To calculate the heart rate if the second R wave does not coincide with a thick line on the EKG paper, the small squares must be counted to the R wave and multiplied by 0.2. The result is then added to the number of large squares, and 300 is divided by that number. 17 by 0.2 equals 3.4, 3 plus 3.4 equals 6.4, 300, 6.4 equals 46.8 BPM, beats per minute. Calculating heart rate using the number 1500. Unlike the previous method, this one counts the number of small frames that are in the RR interval. Then this amount is divided by the number 1500 to obtain the heart rate. It is important to mention that this method, like the previous one, only works if the patient's heart rate is regular. Irregular RR intervals. Examples of irregular RR intervals can be seen here. Six-second method to calculate heart rate. To apply the 6-second method to calculate heart rate, you need to count the number of QRS complexes found in 6 seconds. These 6 seconds are represented by 30 large squares on the electrocardiogram. The number of QRS complexes is multiplied by 10 to determine heart rate. The normal range of heart rate is between 60 to 100 beats per minute. KUBIOS software graph results. Normal values are from resting measurements. Therefore, exercise or stressful situations are expected to produce a higher heart rate and a lower HRV, heart rate variability. The parasympathetic, PNS, and orthosympathetic, SNS, systems indices are calculated to provide an overall measure of these nervous system activities, compared to normal resting values. The recording overview includes an illustration of HR, RMSSD, and stress index, HR time trends. Graphs of time zones dedicated to each zone, stress zones or time dedicated to each stress zone, and energy expended, is, basal metabolic rate, and energy expenditure related to the activity. The parasympathetic index appears in green on the left, indicating a high parasympathetic tone. It is characterized by, read details below the blue. The orthosympathetic tone index appears in red in the center, indicating a low sympathetic tone, is characterized by, read details below the red. Details of the counts for one and the other appear in the box on the right. For the parasympathetic, RR of 1222 milliseconds, RMSSD of 60.4 milliseconds, SD1 of 45.5%, which is, a parasympathetic index of 1.97. For the sympathetic HR of 49 beats per minute, a stress index of 7.7, and SD2 of 54.5%, which is, an orthosympathetic index of -1.46. In this case, the parasympathetic system predominates, and the sympathetic system appears inhibited. It should be emphasized that normal values are measurements of rest. Therefore, exercise or stressful situations are expected to produce a higher heart rate and a lower heart rate variability. The PNS and SNS indices are calculated to provide an overall measure of these nervous system activities in comparison to normal resting values. Based on the patient's clinical signs, tests and specific measurements that confirm the type of neurovegetative imbalance, the appropriate osteopathic treatment protocol will be performed to rebalance the body. These protocol must be completed by the classical exam in osteopathic medicine. References. Here we have the references of the scientific articles used in this conference. Thank you for listening.